Hello, this is Mr. Molo for lesson 1-3, solving equations with variables on both sides. So for this lesson, it's very similar to the last one. The only difference is you're going to have a variable on each side. And we're going to kind of skip the first couple pages just because they don't really have anything to do with solving for a variable on both sides. I mean, they're good lessons for area and perimeter, but that's not what we're trying to focus on. So kind of like before, I'm going to draw my line down the equal sign. And so we're going to try and get the number on one side of the equal sign and the variable on the other side. So that's probably one of the more confusing parts, is deciding which side is which. So for this first one, I have one number, it's 12. It's already on the left side, it's by itself. So I'm going to get the 3x over to the other side. Since it's a minus 3x, I'm going to end up adding 3x to both sides. So negative 3x plus 3x cancels out, and then negative 6x plus 3x is negative 3. So I have 12 equals negative 3x. It's negative 3 times x. So I'm going to end up dividing both sides by negative 3. So I end up with negative 4 equals x. Okay. Second one, we kind of have a choice here of which way we're going to go. So I can either put the variable on one side or the number on the other side, and there's a variable and a number on each side. I like to make it easier, so I like to have a positive variable. So I'm going to start off by adding 5z. You can do it the other way, and you can subtract 5z from each side, but then you'll end up with a negative z. And again, I don't really like that, but if you like it, then go ahead and do it that way. So the only thing on the left side is the 7, and then I have a 17, and then 5z plus 5z is 10z. Okay, I have this 17 over here by the z, so I'm going to get rid of that. It's a plus 17, so I'm going to minus 17. So then I end up with negative 10 equals 10z. And so that's 10 times z, so I end up dividing both sides by 10. And negative 10 divided by 10 is a negative 1. So negative 1 equals z. And then remember, we could be going back in and plugging these in to make sure that they work. So let's look at these first two. So if I have negative 4 as my x, so I have 12 minus, let's do 3. And we think x is negative 4. And that equals negative 6 times x is negative 4. We'll see if that's true. So negative 3 times negative 4 is positive 12. So on this side, I have 12 plus 12, so 24. This side, I have negative 6 times negative 4, which is 24. So I did it right. 24 equals 24. That's true. It's right. If it was something like 24 equals 16 or something, then we know that wouldn't be right. Kind of the same thing with number 2. So I have 7 minus 5z, and I think z is negative 1. So negative 5 times negative 1 is positive 5. So 7 plus 5 is 12. So on the left side, I have 12. Hopefully on the right side, I get 12. So on the right side, I have 17 plus 5 times negative 1. And 5 times negative 1 is a negative 5. So I have 17 minus 5, which is 12. So 12 equals 12. I know I did it right. All right, let's look at a question like number 4. So this one has a fraction here. So, and the fraction's in front of the parentheses, so I know I'm going to need to distribute that. So I'm going to distribute 3/4 to a 48 and distribute 3/4 to a negative 16x. So 3/4 of 48 is 36. 3/4 of negative 16x is 12x. Then over here, I need to distribute that 4. 4 times 4 is 16. 4 times 2x is 8x. And now it pretty much looks like number 1 and 2, like we just solved. Again, I'm going to try to get my x to be positive. So I don't want to subtract 8x from each side, because then that'll give me a negative 20. So I'm going to end up adding 12x to both sides, so that I end up with a positive 20x. Okay, again, if you don't care about the variable being negative, then you don't need to worry about that. Okay, so then I end up with 36 equals 16 plus 20x. So I'm going to end up minusing 16 from each side. 36 minus 16 is 20. So I got 20 equals 20x. Divide both sides by 20. And 20 divided by 20 is 1. So I get 1 equals x. All right, for the last one on this page, I need to go back and erase. All right, so kind of the same thing as well, except now I have some things I need to combine before I can actually do the transferring to one side. So if I look here on the left side here, I have a 6x minus 10x. So I'm going to combine those before I end up crossing my equal line. So 6x minus 10x is a 4x. And on the right side, there's nothing to combine, so I'll keep it as 16 minus 8x. Okay, same thing. I'm going to add 8x to each side so that I know my x is positive. So negative 8 plus 8 is 0. Negative 8 plus 8 is 4x. Bring down my 8. Bring down my equal sign. Bring down my 16. I'm going to bring my 8 to the other side now. So it's a plus 8, so I minus 8. So I'm left with 4x. 16 minus 8 is 8. Then last step, it's 4 times x. So I'm going to divide by 4. 8 divided by 4 is 2. All right, we're going to look at the next page. Only thing about these problems are it has some double distributing. Otherwise, it's pretty much the same thing. So let's look at a question like number 9. Okay, so 2 distributing things here. So 8 times 2 is 16r. 8 times negative 3 is negative 24. I do have that extra r hanging around. 3 times 3r is 9r. And then distribute that 3 to the 2 as well. 3 times 2 is 6. So again, it's kind of like those other two problems combined, where I do have something to combine here before I transfer things to the left side or the right side. So I'm going to do that. I have a 16r minus a 1r. Remember, that's a 1r. So 16 minus 1 is 15r. Minus 24. Right side, I really don't have anything to combine. I have a 9r and a 6, and I can't combine those. All right. And then I have 9r plus 6. So I'm going to subtract 9r because it's positive. So that leaves me with 6r minus 24 equals 6. I'm running out of room here. So I'm going to add 24 to each side. Negative 24 plus 24 cancels. It's 0. 6 plus 24 is 30. So I have 6r left on the left side, 30 left on the right side. 6 times r, so I divide. 30 divided by 6 is 5. And then also another difference about this back page is it says right here, if I erase that, it says determine whether they have one solution, no solution, or many solutions. Okay, and we'll kind of see there, everything we just did right now is a one solution problem. A one solution on number 9 is 5. 5 is the only number that works for that. The one solution on number 1 is negative 4. We proved it because that's the only time that 24 equals 24. Okay, the one solution on number 2 is negative 1. We proved that one as well. We double checked our work. That's negative 1 is the only number that would make both sides of the equation equal 12. We didn't check our work on 4 and 8. Trust me, they're right. 1 is the only answer for number 4. And then 2 is the only answer for number 6. Okay, so on the last page there, we have to determine if it's going to be like that, where it's a one solution problem. So I won't do any examples like that because those are the ones we just did. I'm going to do one of each here where we get a no solution and a many solution problem so you can kind of see what they look like. All right, so number 11. So first step, I'm going to distribute that 6. So 6 times 4s is 24s. 6 times 12 is 72. 8 times 3 is 24. 8 times 3s is 24s. and 8 times a negative 14 is a negative 112. So you might already see a difference here. Something looks a little strange. Like up here, nothing was really the same, but you can already kind of tell I have my S's are the same. I have 24 S's on this side and 24 S's on this side. This is also another reason why I like to take care of my variables first instead of the letters, is for problems like this. So I'm going to combine my 24 S's here. It's a positive 24 S's, so I'm going to subtract 24 S's. If I do that from both sides, 24S minus 24S, oh no, they cancel out. It's 0 S's. So I'm only left with 72 equals negative 112. I mean, kind of have to stop and think, is that true? Does 72 equal negative 112? And it does not. That is false. And when something is false in math, we say it is a no solution. Okay? So there's no way that you're going to come up with an answer for S that makes the left side of the problem equal the right side of the problem. Doesn't matter how hard you work, never going to happen. It's not going to equal out. All right, let's look at number 12. So same thing, I got to distribute here. So let me rewrite the left side. Nothing needs to be done to the left side though. So we'll just rewrite 16F plus 24. So 8 times 2F is 16F. 8 times 3 is 24. Again, something strange happened. We have, just like over here, 24S, 24S. Over here, I have 16F and 16F. Except now, when I subtract 16F from each side, oops, F, not T anymore. Subtract that. My 16F and 16F cancel out, so I get 0 F's. Well, on the left side, I'm left with 24. And on the right side, I'm left with 24. Does 24 equal 24? Yes, it does. That is true. So when it's a problem like that where it's true, 24 does equal 24. That's what we call infinitely many solutions. We abbreviate that by IMS. So one solution problems, all the problems we did before that where you just get a number. No solution problems, when you end up solving it, you get stuck at this point. 72 equals negative 112. That is false. 72 does not equal negative 112. So that's a no solution problem. Many solution problems, or infinitely many solutions, is when we have the numbers equaling each other and it ends up being true. Yes, 24 is equal to 24. 17 is equal to 17. 2 is equal to 2. Doesn't matter what it is. As long as it's true, that's many solutions. Same thing with 11. As long as it's false, doesn't matter what it is. 2 equals 3. 7 equals 1. As long as it's false, it is a no solution kind of problem.